Okay, thank you very much. If there are technical problems, if I get interrupted, if the stream is disconnected or something, you need to tell me. Okay, so hello everybody. Thanks for coming to the talk about recheck and the philosopher's stone. And this talk is about how to turn selenium, if you know selenium, which is a chemical, is also a test framework and chemical, and how to turn it into Adamantium, making it essentially unbreakable. If you have any questions during the talk, I want to ask you to use slido.com, as you have probably been doing through the whole conference. There the code is TCM 2020, and unfortunately, I'm not very fluent in Russian, so please post your questions in English. Okay, the reason I am giving this talk today is, that we are also having an open source project, and if you like what you see, then it would be very cool if you could star us on GitHub. And unfortunately, I didn't remove that because usually I give out stickers at talks, but today, since I'm not at the venue, I would have to use that one. So this time you don't get a sticker, but next time you see me, you can always approach me, and I will give one to you. Okay. So today I want to talk about how the current state of testing is maybe not optimal. Okay, so no problem. So again, if you want to write a test for an umbrella, you would probably write something like that you expect the umbrella to open. However, this doesn't suffice. As you can see, the umbrella opens, so the test does pass, but something unexpected happens as the head of the umbrella comes off. And it's very hard to write a test for that. Now that you could, adapt your test accordingly, but it's very hard to write that in advance for something that you didn't expect. And this is unfortunately the state of the art currently in test automation. So I just want to use a very brief example, which is a Selenium test, and should be very easy to understand. Essentially what it does here, this is the main part of the test, is it logs into a system and then afterwards checks that the success message is being displayed. So if you see the test execute, you will see a login page open, username, password being filled, and then the test clicks on sign in and checks that success is being displayed, which is the case. So the test is green. Unfortunately, if you now change a very minor detail, single character of the underlying HTML and execute the test again, then you will see that from a user's perspective, this is an unexpected change. From a user's perspective, now the website is essentially broken. So as you can see, it's rendered very differently and it definitely looks broken. However, that's not what we check. All we check is the success message, which is still being displayed, so the test is green. Now let's revert the change. And now if I change the ID of the username input, which is being used here in order to identify the element. The problem is that this ID is nothing that's being displayed on the screen. So the user doesn't know about that. The user doesn't care about that because it doesn't even see it. However, if we change that little detail, now the test breaks. So now the test cannot execute anymore and becomes threat. And this is essentially the state of the art in test automation. So the test breaks with something that is unimportant to the user, that the user doesn't care about at all, but the test does not detect if the CSS completely is gone, because this is simply not reflected in the test. This is a very sad state to be in. So instead, we propose a different solution, which is recheck. And in order to use it, you just need to adapt the test code in that you use the recheck driver. Now, if we again change CSS and execute, Oh, sorry. Now you see that the website is broken. The CSS doesn't load. So from user's perspective, this is a very, very important change, although it's just one character. Now it's slow for some reason. I don't know why. Okay, so it fills username and password. Why is it so slow? Usually it's fast. I'm sorry about that. I don't know what happens. Something's clogging up my CPU. So the test now fails and detects 182 differences. So a lot of differences, and it even tells you which one. So it tells that the color has changed, that the display has changed, the background has changed. So you see that a lot is going on. Let's undo that change, and let's now change the ID from username to user. Sorry. And execute the test again. And this again, the test is using the ID to identify the element it wants to interact with, just as before. So this is just the same. This is the way we identify the element. And this time, the test is still able to execute. I don't know why it's so slow. Something is clogging the CPU. That happens with live demos. Okay, I don't know what that. So usually it's able to find the element ID still. So something is wrong. I don't know what I did when I prepared the demo, because it's just a couple of minutes before it worked. Okay. I changed something else. That's the reason it's so slow. I'll have to look into that. And the reason why this usually works, and so sorry about the demo effect, is that we do one thing different. So the idea behind that open source tool is instead of defining the outcome, you simply approve it. So you have a look at the website or at the whatever it is you test, your application, and then you approve it, and then the tool makes sure that nothing changes without you noticing. And our idea behind that is that an automated test is not actually a test. An automated test, if you think about that, if you do a manual test, you look at everything that's strange, everything that doesn't look right, everything that is suspicious, and try to pinpoint to failures or to problems. However, with an automated test, the test just executes and makes sure that everything stays the same as it was before, whether that makes sense or not, whether the circumstances or the situation changed, and this which has previously been correct now becomes wrong, the test doesn't care about. It just shows you if there's changes or not. And in that regard, an automated test is more like version control than actual testing. We do have version control already. We have Git, for instance, or SVN or whatever tool you use. However, that version control only answers the question, where has the code changed? However, as you all know, code is not the sole thing that defines software. So unfortunately, software is much more than just the code. Software is also configuration, runtime system, data, user input, and a lot of other things. But what the user cares about is not the code. The user doesn't care about code. The user cares about his software. And he wants to see where the software has changed. So this is what we want to know. This is the reason why we use test automation, because we can't directly test or see where the software has changed. We use test automation to close that gap. So in a way, coming from that perspective, automated tests are more like version control than actual testing. So what we do is, in order to achieve, to better suit our needs, to better fill the need of version control in automated tests, what we do and suggest to do is called master testing. There's a couple of tools already with golden master testing. One is Jest from Facebook. One is approval tests and recheck web, and there are a couple of other in addition to that. However, the problem with golden master testing usually is twofold. It comes with two challenges. One is noise, and the other one is redundancy. And I'll go into that into detail just a second. So the first one is noise. What do you mean by noise? Well, the problem is that since automated tests are version control, you will be shown differences that are irrelevant for you. Maybe the build number has changed. Maybe the date has changed. Maybe other things have changed that you really don't care about. And then you don't want to see them. So if you think about from a version control perspective, then if you write an assertion about something, about anything really, then it's like writing that you want to be notified if that has changed. So if you think about our example here with the success message, it could very well be that we want to change the success message, that at some point we want to say, hello, Simon, or hello, username. And then you need to adapt the assertion statement and enter the new correct behavior. So that means that an assertion is not the unchangeable truth. An assertion is just something that you want to check as it is right now, and it might change as well. But right now you want to make sure that it doesn't change without you being noticed, in the sense that the test fails. So in a way, you could say that it's a deny list of changes. You write down what cannot change without you noticing. That's a deny list of changes. On the other hand side, you have an ignore list of changes, meaning that with git ignore, you probably know that you have to define all kinds of, or ignore all kinds of files that otherwise would show up as changing constantly. Log files, class files, target files, anything that results from the build, jar files, depending on what kind of software you create. There's a lot of files, temporary artifacts that are being created and changed all the time that you don't care about. So in order to ignore them, you create the git ignore file with an ignore list of changes. And our testing behavior, our automated test, is somewhere in between, in that gray area. So if you have no git ignore file or no ignore list, you check everything. If you have no assertions, then you check nothing. But in reality, you want to check, something in the middle. So there's an ideal amount of checks, and there's somewhere in the middle of that. Now, however, there are two aspects to that. One is on which side do you want to err? Like when you make a mistake, what are the odds of you discovering that mistake? And there's the example from Google, for instance. So if you're if you're a tester at Google, you might you might see the dancing unicorn on the screen, and that means that you need to test that component that has that dancing unicorn as a marking very thoroughly, because it has been adjusted, it has been changed in some way. However, the problem is that at some point they forgot to remove the markings. So suddenly the customers had dancing unicorns on the screen. Obviously, nobody thought about writing a test case for that, which again emphasizes the point that I tried to make earlier, is that you can't write an assertion for something that you don't expect. So if you don't think that ever there could be dancing unicorns on the screen, you don't write a test case for that. And this is actually why it's more safe to have an ignore list of changes. If something changes unexpectedly, you can just ignore it if it pops up. But if you forget to write an assertion for it, then you will never know that it happened. And at least in our experience, the ideal amount of checks is typically that you want to check more rather than less. So it's a problem to Oh, just very sorry. Nicht schlimm, Nora. Geh schneller zu der Oma. Nicht schlimm. I'm very sorry, that was my daughter. She came home early from school, unexpectedly so. This happens when you stay at home. Okay, what I wanted to say is there's an ideal amount of checks, and typically you want to check rather more than less. And this is also the reason why we call our system, the open source system that I'm talking about, Git for the GUI. And instead of having a git ignore file, where you put in different entries to ignore specific files, you can ignore specific elements of the HTML by, say, ignoring specific attributes, ignoring specific elements completely, or subtrees of the HTML, of the DOM tree completely, or by mixing that. So you can identify a special element where you want to ignore a special attribute. And because that mechanism is so powerful, we went to use it further, and we called it filter. So we have a filter mechanism, and I just want to give you a very brief example of that. So there's two files. You can still see the screen. So there's two websites, and if you see that, they are very different from one another. So if you compare those two websites, you can see that they're really, really different from one another. And you can now compare them using a test or using our tool, the open source tool. And then if you do that, obviously, there will be many, many differences showing up. So as you can see here, as expected, there's a lot of differences. But now what you can do is you can use the filters here to dynamically understand what's going on. So you can, for instance, ignore the style attributes, and you can ignore invisible attributes. And by the way, these are predefined filters that come with the tool. But of course, you can define your own filters. So you can define your own filters, as you see here, my own, and those will be loaded into the tool or used at other places. Really sorry about that. It's a school calling because of my daughter. Really sorry about that. Okay, so what we have here is, as you can see, a difference in the amount of money that's being shown. So here it's $45. Now it's $50 where it used to be $45, and $115 where it used to be $120, and that difference is showing here. Out of the many differences of this page, this is probably what is relevant to you. I mean, depending on the situation, depending on what you're looking for, but this is a very interesting difference that has now been pinpointed. If you would do, I mean, there are other tools that do golden master testing that are pixel-based. If you do pixel-based comparison, then this is what you get. A situation that says, oh, look, everything is different. Which is unfortunately not very helpful. So yeah, instead we suggest using the tool and get more meaningful differences, because this is a semantic comparison of the actual CSS attributes of the website. And what is very interesting, it also works in situations where pixel comparison doesn't work at all, say with animations. So if the animations are defined within HTML, or if it's a video maybe, and the link to the video changes, then we can show that with a typical pixel-based comparison. You just get that there's a difference. The other problem I talked about, why it makes sense, or the typical challenges that come with using golden master testing, is redundancy. And by redundancy, I mean that if you have, say, 100 tests, and you change the logo of the website, then you suddenly have 100 failing tests, because every test is telling you, oh, look, there's a change. And now you have to maintain 100 tests, which can be cumbersome. We addressed that issue by tool support. So instead of, if that's the only change, and again, here you can use filters to filter out changes that you want to apply. So if you want to maintain the golden master, with 100 tests, you can just commit that change. So here you would change, all. You would apply all changes, but obviously you can use a different filter and just apply the change to the logo and see what is the rest. And the other tool, so there's two tools for that actually. This one is a CLI command line interface tool, and the other one is the GUI that you can use. And now I wanted to show you why it works, that the test can still identify the elements to interact with by its ID. So even if we change the ID, as I showed earlier, the test can still find the correct element and interact with it correctly. So the way this works is that, and it doesn't need to be the ID. It can also be the text. It can be the link text. It can be the XPath. It can be the CSS, whatever. So it works essentially for everything the same way. If the element can't be identified by the ID, then if the ID has changed, then what we do is essentially we create a copy of the website to compare against the new version. So in the old version, in our copy of the website, we still have the old link, button, whatever, with the ID. So we can simply go to that version, to that copy of the website, and find the element there by its old ID. And then we compare it to the current version of the website, which we do anyway, because we want to show all the differences, right? We have create a one-on-one assignment of all the elements to the new elements. And therefore, we are able to pinpoint to the change in a very specific and very robust manner. So even if that button changed completely in terms of color, in terms of ID, in terms of CSS, in terms of XPath, and if the only change, we can still correctly identify the element. I'm very sorry. I have to shortly. Apparently, there's a problem with my daughter at school, and I just need just a minute to clarify the problem. I'm really sorry about that. It's something very urgent, and I need to attend this now. Otherwise, I will be called every 2 minutes from now on. Kerstin, ich bin gerade in einer Konferenz. Ich halte gerade einen Vortrag. Die Nora ist gerade gekommen und ist jetzt nicht mehr zu der Hildegard gegangen. Ich weiß es nicht. Sie hat geweint. Ich nehme an, sie ist aus der See heimgegangen. Aber ich bin gerade mit der Konferenz. Ich halte gerade die... Ciao. Okay, I'm really sorry about that. First time that happened. So there's a problem with my daughter. She came home unexpectedly from school because usually she should stay longer, and now the school is looking for her, and my wife is looking for her, and I'm the one who saw her, so I had to clarify that. Sorry about that. Okay, so as I said, we create this one-on-one assignment that's very robust to changes, and what we can do then is still correctly identify the element and return it as a best match. And then we log that change. So what we do, what you saw earlier here is that we found the element correctly, but we have a specific confidence that is predefined, so a threshold, and because apparently I had other changes to the gold master that I didn't update, as you can see, we correctly identified the element, but we didn't use it because there were too many changes. So you can define that threshold as any way you want, but obviously if we're not sure that it's the correct button, we'd rather just notify you and continue with the rest. So, but what we do is we also log that. So now you have the possibility to update your test case, because what happens obviously is when you apply the change to the golden master, then the old ID is also gone in the golden master, and then the approach doesn't work anymore. Or if you don't apply to the golden master, then this happens, what I just showed, is that the golden master and the website diverge even more, and over time, at some point, we will be unable to correctly identify the element, or the threshold will be just too low. So what you need to do is at some point update the Java code, the test code. So either you use the new ID, and we can, with a commercial tool, we can even do that automatically, or instead use the retest ID. And with that, you won't ever have to change the ID in the test case ever again. And why is that the case? Because essentially what we do is, when we create the copy of the website, when we create the golden master, we insert additional attributes, namely the retest ID, into the copy of the website. And because it doesn't, these are IDs that are not on the live website. They exist only in the copy of the website. So they can never be affected by change. Whatever happens to the live version of the website, these can never change because of that. So the only real problem is if the website changes in such a way that the element is not being displayed. Then obviously it doesn't work anymore. And the underlying idea is still the same. We go to the copy of the website, find by retest ID, do our one-on-one assignment, and return the best match to Selenium to continue with the test. And funny enough, this also addresses yet another reason, or yet another problem, because sometimes people even have problems identifying the correct element without any change. So I don't know if you've seen that tweet. People write code like this, and I'm proud of it. So as you can see here, it's a very complex CSS selector, root, div, ul, li, div, p, to identify a specific element the test should interact with. However, obviously this is very unintuitive. So it's very hard, if you read the test, it's very hard to understand what the problem is, or what the element is, what the element does. So instead, what you can do is you can use a retest ID, and you can give it a semantic name. And every element of the website has a retest ID. So it's very kind of easy to use the retest ID to identify that element that you want to interact with. Something else that you can do with that is that you can create data-independent tests, meaning that you can completely change the website and the test doesn't need to change. The only thing that needs to change is the golden master. And I want to show you that now. So here, obviously, I changed the website, and this led to the problem of the breaking test. So what I can do now is I can go, sorry, where is it? Delete that. So I now execute the test case. It will fail because the first time I execute the test case, it has nothing to compare against. So in that case, I deleted the golden master. So it's like first time executing the test case. You can't do any comparison. So what it will do instead is it will now create the golden master for later comparison and put it, depending on how I configured my project. So this is a Maven project. Put it in the appropriate place. So now you will see the test failed because, and it says so, because no golden master found. So what we do now is now we have here a newly created golden master that we can compare against. Here it is. Now what I want to do is I want to demo that again. So I change the ID. Again, the ID is being used here. And if I execute the test now, with the Selenium test, as you saw earlier, the test did break, meaning that the test was not able to proceed with a different ID. However, as you can see here, we are now able to correctly identify the element based on the copy of the website that we have, and still the test can continue and can correctly execute. Now I can load that report. into my GUI, for instance. And here I will see that the ID has been changed from username to user. And this, by the way, is the reason it's green is, by the way, because I ignored that change here in my recheck ignore file. So here I have a recheck ignore file where I set ignore ID, and this is the reason that the ID change has not shown up. Now what I can do is I can say accept, and if I apply the change, not only will now the golden master be updated, but also my test case. So now we are able to automatically change the Java file and update here, update from username to user. I hope you saw that. It was a bit slow. So now I can automatically maintain my test case. And all of that even without AI. So meaning that I now can create data-independent tests. Tests that just execute, and if the data that is being displayed, say the calculation data, the whatever, I don't need to update the test, I just need to update the golden master. So overall, the benefits are you now have a rule-based deterministic ignore. It's open source, you can use it offline. It gives you, in a sense, unbreakable Selenium and auto-healing tests. And in principle, it works for any technical interface. So both XML, JSON, we have proof of concepts for that, and as it saw, a web. People that have tried it so far very much like it. So I would encourage you to try it as well. And it's on GitHub. So you can find it under GitHub, retest, recheck web. So now I will just take 1 minute to talk a bit about why we do that, why we created that project, and why it makes sense for us to make it open source. And the reason is, so part of what you saw, so the GUI, the CLI, the CLI and the API is open source. The GUI is something that we sell, and the main reason we do that is because of AI. So you might have heard that AI is able to solve testing because 99% of companies face challenges in testing and test automation. And right now in the software development lifecycle, testing is the bottleneck because of AI being able to address today's needs. Like, I mean, it's the major buzzword, and we wanted to apply AI to testing. However, the problem is the main problem is the Oracle problem, meaning that the AI doesn't know whether the result is correct or not. And other things we addressed are creating meaningful tests and tests maintenance. The Oracle problem simply means that if the AI finds a bug, it won't recognize it as such. And we addressed that obviously with the golden master testing. So a human has to test once, and then we're able to find if there are changes. So it's not right or wrong, it's just different. What we do also is we apply two different AI systems, a genetic algorithm and an artificial neural network. With the reason being that artificial neural networks typically tend to have tend to need a lot of training data, and that doesn't make sense for most smaller projects. So what we do is we create a pre-trained network that learns how a typical user uses a typical software, and instead you can just give 1, 2, 3, 4, 5 examples to a genetic algorithm, and that will then be applied to your specific project or your specific problem. So overall, it looks like that. You test manually to find whether everything is correct. By doing so you can already train the AI, and then the AI will automate for you, and you will only have to look at the differences from one version to another. As I said, we train the AI to create meaningful tests to do what a typical user would do. Meaning that, for instance, for a web shop CRM system, the AI will just follow the user experience nudges, the user design nudges. So you click on the bigger button so here, for example, on the bigger button, on the most prominent, more distinct, more interesting button, and follow what the user or what the designer wants the AI to do, or the user to do. So in summary, you have open source difference testing with whitelist creation, easy creation, and maintenance of test cases, and Unbreakable Selenium, which is easy to use, allows you even to define your own IDs independent of the website, and gives you the ability to create data-independent tests. So now I finished, I think, right on time, even though I was distracted. Sorry again about that. Do you have any questions? So let me update the slide with live questions. Okay, I don't see any questions, is that correct? Okay, so this is Slido. Do you have any questions? This does not seem to be the case, or I'm not sure. Am I still connected? Can you hear me? Hello? Am I still on air?
Yes.
Ah, hello.
Hi.
Hi.
You are on air. I don't know. Do we have any questions here? Just a second. Can you click on the link in the left bottom corner? There should be a presentation view or something like this.
Left.
Here.
Presentation view. Unfortunately, this is all in Russian, and I'm not that familiar with the Russian.
No, left bottom corner. Yes, right there.
That one? I can't understand it. I can't.
Presentation view. Yes, I think it's here. I don't know because it's no good. Pixel perfect. Oh.
Is that correct?
I think so. Click on the big green button.
Ah,
yeah, that's
okay,
right. We need to choose a whole number 2, 3, whole number 3.
Ah, thank you. Ah, okay. Oh, yes, thank you. Very good question. Yes, so Retest is a startup, and unfortunately, mostly due to Corona, we have been unable to secure our follow-up funding round. So this has been promised, but delayed a couple of times. So right now, we are, the company, the startup is in insolvency. However, we will continue to support the tool, and we will continue to develop the tool. This is something that we agreed upon as team, and that I think we will follow through. So to answer the question, yes, we will support the tool. And also there are right now talks about it being sold. So the open source part will be supported in any case, and the commercial part will probably continue as well. So we are just talking about that. Thank you that you found that interesting. I'm very glad about that. So how does the approach deal with dynamic pages? Very easy. I mean, we just do a, let me show you. So essentially what we do here is we create a golden master per interaction. So after sending a key, first of all, after loading the URL, then after the first send key, second send key, and then the click, there are 4 golden masters being created, which reside here. So this works very easily also for dynamic pages, no problem at all. If you want to reduce the amount of golden masters that is being created, that you shouldn't care about because we are automatically maintaining that. But if for some reason you want to do that, you can explicitly create them. So instead of having them created after an action, you just use recheck, which is the same library, and then call read.check, and then after, say, 10 actions or whatever, then golden master is created and compared against that. Okay. Next question. Do you have flaky tests? How do you reduce the number of flaky tests? My experience is that typically you have flaky tests only in the beginning. So after when you first set up a project, what you have to do is maintain the recheck ignore file. So this is something that you need to do, and diligently so. But fortunately, this is a global file. So you set it up once for a complete project, and then you can reuse it throughout the project. And you can, for instance, if depending on what you want to do, you can use predefined filter, and for instance, ignore all styling information. And if you do that, then typically you don't get flaky tests anymore, unless the website changes really, which then you want to know about that. So, but that's not what I would call a flaky test. So thanks for asking. Next question: is there is a chance if there is a changes on the page that we expect to be there in new version? How should we deal with that? So essentially, the golden master is XML. So here, here's XML. So what you can do is either you can create the XML such that it matches what you expect. So you can, for instance, if you expect a certain new text, you can make that change here in the XML file, or let's see if I understand correctly. Yeah, that's probably what I would do. Change the XML file, or just wait until that change happens, and then you will be notified about the change. How many participants use your library? Thank you for the question. Actually, that's not easy to tell because it's open source. So the commercial product is being used also by a couple of customers, but this will perhaps change now that we're insolvent. So we have stars here and a couple of forks, and unfortunately, I don't know if it's possible to see in Maven how many people download the library. So it's not actually very easy to answer the question. If you have a specific traffic, maybe if you have a specific, this is all open source, you can all have a look at that. I don't know, if you have a specific question, maybe I can answer that better, or you can have a look on your own. So it's very hard to tell, actually. We do have open source requests, we have change requests, we have even people contributing, so there are people using it. But I don't know how many. Okay. There's an additional question. What is the principle of the retest ID creation? Is it one ID per HTML tag? Yes. So that's essentially what we do. Every element has an HTML ID, and you can come up with your own way to do that. So what we do here, we have options that you can use. So you just add them here. And then here you can define, for instance, how to use retest ID provider. Check. Yeah, you can define your own retest ID provider, and then that will create IDs, retest IDs for any element. So what we typically try to do is do this in a sensible way, meaning that we create a retest ID based on the text, based on the, I don't know, the HTML ID, based on something that is semantic and sensible in any way. But you can do it purely random. So you can just use a UUID, for instance. So it doesn't really matter as long as it's unique. you can come up with your own retest ID creation strategy if you want. I hope that answers the question. Any other questions? I think we're also out of time, if I'm correct. So you can always contact me on Twitter. So here you have the contact data on Twitter, via email, and on LinkedIn or whatever. And also you can create tickets here in the open source tool. Yeah, if you have any questions later on, please feel free to contact me. Otherwise, thank you very much for attending.